Hello everybody, welcome to my channel. Today we have a very good problem for you guys called the next greater element 1. So this is a very good problem, so make sure you pay close attention to the problem statement, right? So it says given a no, I'm tripping. So it says the next greater element of some element x, right, in an array is the first greater element that is to the right of x in the same array, right? So we're given two distinct zero index integer arrays, nums of 1, nums of 2, where nums of 1 is a subset of nums of 2, right? So for each I, right, nums of 1, right, find the index j such that nums of 1 is equal to nums 1i is equal to nums of 2j, and determine the next greater element of nums of 2j and nums of 2. If there's no greater element, then the answer for this query is -1, right? So return an array answer of length nums of 1 length such that the answer of I is the next greater element as described above, right? So very kind of tricky problem statement, right? Trying to confuse you. So essentially what they're saying is we're given those two nums of 1, nums of 2, right? There's two arrays. And nums of 1 is a subset of the numbers of nums of 2, right? So just a subset, pretty much sees the sum of the numbers from nums of 2. So that's kind of what I need to see it, right? So 4, 1, 2, they exist in the original, right? Because they're a subset of this one. So yeah, so our job, right, is to find their next greater element, right? So for those chosen numbers, right, they're originally from nums of 2. We need to find, right, their corresponding next greater element in the original list, right? So for this example, nums of 2, so we see 4, right? We need to go ahead and nums of 2 find its greater element, right? That is to its right, not to the left, but to its right. That's kind of what the definition was defined, right? The first greater element that is to its right. So yeah, those are the rules. So we have 4. There's nothing there. Therefore, but -1, because that's what they said they wanted us to return if there's no answer for that particular number. Okay, so for 1, its next greater element inside of the original list, right, which is 1 is 3. That's the first greater element. You see, there are other greater elements, 4 and 2, right, but they're not the first ones. So we return 3 as the first one, right? And then we put 3 there, and then we see for 2, next greater element is -1 because there's nothing to its right, even though there are numbers to the left of it that are greater than it, right? But they don't like fit the requirements, right? So that's what we end up returning -1 for, right? And this example is kind of the similar thing. So we try to find, right, for those chosen numbers, right, find for each of them, right, in the original list, the first greater element that exists to the right. Okay, so we see 2, that first greater is 3, and then we see 4, there's nothing there, right? We return -1. So kind of pretty simple, right? So how can we go ahead and solve this particular problem, right? We normally like to start off with the most intuitive approach, the easy approach, right, without being clever, slick, right? What I'm thinking is just for each of those chosen numbers, right, do a loop, right? So for each of those numbers, loop in the original list, right, the bigger, right, nums of 2, right, trying to find a number that's bigger than it, right? So we go ahead 1, 3, 4, all right, we see 4, and then from 4 onwards we loop, right? Boom, boom, boom. We see that at 4 there is no greater element there but -1 for that particular thing, right? So this 4, but that's the result, boom, right? And then we see 1, for 1 we loop through, we find the first one, put 3, boom. For 2, finds position, right? And then once we find the position, because we need to find a linear loop to find its position, right? And then after it finds position, we need to loop through onwards, trying to find, right, if there exists a bigger number, right? If there's no bigger number, start from that position onwards, then we put -1, okay? And the number has to exist to its right, right? So we need to find its location. Once we find its location, then loop through, right? So as you guys can see, the time complexity for this one would not be very efficient, right? We have nums of 1's length times nums of 2's length. That's the time complexity, guys, right? It's not gonna cut it. How can we improve, man? How can we be a little bit more clever to kind of bring down this time complexity here, okay? So maybe I can do some pre-computation, right? Maybe, right? I'm trying to avoid like looping both arrays, like twice for each of them. I can't really explode here. Okay, so the constraint says all the numbers are unique. Very nice for them to say, and those are okay. So it's very important to look at the constraints, right, that are given to us, right? It can kind of help us to craft the algorithm, like accordingly. Okay, that can really help, right? So what I'm thinking here, right, is that maybe we can do some pre-computation here. Okay, So we nums of 2, right? Essentially, we can just have nums of 2 here. Right. So for nums of 2, we try to find the next greater element for each element here, right? So what I'm thinking here is to do a double for loop. For each number, right? We put the answer in the map, right? So for 1, we find the next greater element for 1. Okay. Then we do it. For each index we keep looping. So a double for loop again, right? But it's over the same thing. It's not very efficient, right? So just it's gonna help us lead us into the right one, right? So we loop through. We need to find its next greater element, so we put 3 as the answer. Okay. Then we go on to the next number, and we see 3. Find its next greater, right? Its next greater is 4. Okay. Then there's another index from 4, and then from 4 we have another loop that loops the rest of the array, right? Because I was doing this for each one of them, right? So from 4 we loop the rest of the array. Okay. We find nothing. There are no numbers greater, right? It's pretty much a wasted loop. And then from 2 onwards we loop through the rest, right? Then we find nothing as well, right? So this double for loop thing, right? So we have this. We did some pre-computation here, and then what's left for us to do now, right, is to loop through the original array. The original array we put here. Then we put the output result. This is the output result, and then what we can do, just do simple O1 lookup in our map that we've built, right, of answers. So for 4, we put -1 here. Okay, that's the answer there. And then for 1, we see our, what was this thing? 3. We put the answer there. Just like that, we were able to build the output result, and then return that to the answer, right? To the color. So you can see that, even though we, did some pre-computation, its complexity is nums of 2 times nums of 2's length, right? So not gonna cut it, guys, right? This double for loop thing has to be, we have to remove that, maybe how can we do that? Okay. So we did a problem similar in the past where we kind of introduced the idea of so the question was about the daily temperatures, right? Where we need to find for each day its next greater temperature, right? The hotter temperature, pretty much a value. So pretty much another index, another day that had a value greater than that particular day, right? Okay. So we did that problem and it was pretty good. So if you guys haven't seen it, I highly suggest you guys go check it out. It's a very good introductory problem to this kind of problems, right? Where you're trying to find the next greater or the previous greater, right? Or minimum or whatever, right? So this thing is a very good thing to master. So we're going to utilize some of those techniques, right, in this particular problem because it's kind of very, very similar. Okay. So the idea that we came up with at that time, right? So for each number, you see that we need to find, right? We need to loop the rest of the array trying to find a potential match or potential answer, a potential number that is greater than it, right? So that we can find, like, put the result and be sure of that, right? So maybe what we can do, right, since we don't know what numbers are present in the rest of the array, right? And it's kind of hard, not very easy to do without, looping through or storing some kind of state, right? So what I can do, kind of reverse our logic, right? So instead of trying to provide an answer right away, maybe we can put it in some sort of put those numbers in some sort of a waiting list or waiting area, guys, right? All right. So essentially, the waiting area list is equal to an empty, right? So there's no numbers there, right? So what we're gonna end up doing for each number, so 1, we put 1 in the waiting list, right? And then since we're looping linearly from left to right, we could answer its question maybe at future iteration, right? If we end up encountering a number that's greater than it, right? Since we're going from left to right anyway, and this number's there, and if there exists a number that's greater than it, we'll be able to answer its question at that particular time. But for now, we can't answer its question, so we just put it in the waiting list here, okay? So we put 1, and then we go into the next iteration. Then we see that number is, in fact, greater than it, right? So you see how we can answer one answer right away, right? Without having to loop through it again, right? So we can enter its question, then we put that number there as well, right? So that maybe in future iteration, we can answer its question as well, okay? So we put 3, then 3 goes to the next iteration, right? And then 4 is 4 greater than the element that's waiting in the waiting area. Okay, it is greater, so therefore, A can answer its question there, okay? So 3 should be 4, right? That's the answer for 3. For 2, for 4 now, right? So now we need to put 4 in the waiting area so that it could wait for its next, for the next greater element, right? So 4 gets added, and then we go on to 2. Is 2 greater than it? No, it's not greater than it. So it joins the list as well, right? Because no, and 4, right? So we end up with nothing, right? So those will be left with this one, right? -1, and 2 as well will be -1, right? Because there are any answers for them, right? And you can see that, you know, what we have here, right, is a monotonically decreasing sequence, guys, right? Okay. Right. And so pretty much what we could do, right? We see that we've built our output results. And what we got to do now is the same thing that we did, just so one lookup for these things. Okay. For 4, there's -1. For 1, there was 3. And for 2, there was -1, right? No. So as you guys can see, right, you know, we have this monotonically decreasing sequence, right? Okay. So let's say now we ended up finding like a bigger number, right? Let's say for 3, for example. Okay. So 3 now checks, right? Which numbers can I have clear out first? Okay. 3 checks 2, right? Am I greater than 2? Yes. Therefore I can answer 2's question. Okay. All right. See, I don't need to ask the things that are, you know, deeper in the stack first, right? I only need to ask anything deeper in the that came before 2, right? First, right? Because 2 is the smallest elements in the waiting area. Because if 2 was greater than any of the elements in the waiting area, then it would have been able to kick them out. So therefore, it wasn't able to kick them out. Then, you know, it must mean that it's smaller, right? Because if 2 was greater, it would kick them out. So that's kind of an interesting way to look at it. So it was able to kick 2 out. So 3 checked 2. Right? I can answer 2. Then I change myself. Then I'm the answer for 2, right? Okay. And then this 3 would check again. This thing is not greater than boop, nothing. Then it would join the waiting area as well, guys. Right? It's kind of how it is. So we always check the last element because that's the minimum element. So it always checks with the last element that we've added, right? You know, because that's the minimum element in our list in our waiting area. Okay, so it's kind of the main gist of things here. So hopefully it made sense, right? So this particular pattern is called monotonic stack, guys. That's kind of the whole reason I brought it up, right? The stack because we checked the last one element added, and the monotonically decreasing because, you know, this is how it's formed based on this particular idea, right? So if it was the next least element, then the stack would have been so if this one is monotonically decreasing, right? And if it was next least element, then it would have been monotonically increasing. Okay, because the numbers will get bigger and bigger in the waiting area, essentially, right? Since they're getting smaller and smaller in the waiting area, that's why it's called monotonically decreasing here. Okay, so let's quickly go ahead and code that up real quick. So like I was saying, guys, the code will be even simpler, right? Very, very simple code. So we're gonna have a stack of integers. So a stack. Okay, we have our stack ready to go. So we also said we would be introducing this map, right? This map is going to be interesting for us because it's going to allow us to store those numbers, all right? When we're doing the pre-computation, right? And since the numbers are unique, right, we can store it in a map and store the result also in a map, right? So it's kind of how we're able to get away with it, okay? Just store the actual values here and there. So now we'll be doing the computation, which is a linear loop through our nums of 2. Okay. Okay, what am I doing here? So nums of 2, that length, I plus plus. And we said for each of those numbers, right, we'll push them into the waiting area essentially. So nums of 2 of I, right? So we push them in the waiting area, right? Okay. So now we also need to know, let's say if the waiting area is not empty, right? We need to potentially, right, we should try to clear it out, right? And for this particular number that we're on, okay, if the particular number that we're on, if it's greater than the element at the top of the stack, which is the minimum number in the waiting area, all right, that's why we do that check first, okay? So if we're greater than the minimum number in the map and our list, then what we end up doing, then that means that this number that we're on is an answer for that particular number. Okay, so therefore, so now we can remove that number in the waiting area, and then we could add the current number that we're on as a potential result for that number. Okay. So we remove that, then we go ahead and check the next minimum number, right? You know, the second minimum number that was in the waiting area. We pop, if it's still greater, then it keeps clearing out the waiting area as much as it can, as long as this condition is true, which is that is greater than that element. Okay. Yes. So after we do that, guys, we're in good shape. We can go ahead and start building output results. We have our array, which is going to be of size nums of 1, that length. Okay, so we do a linear loop, but this time over nums of 1, I plus plus. So now the answer is going to be res of I is equal to map that get or default. Okay, so we get the actual value of that number. So with this case, we set 4, get its value in the map, right? That's kind of what I'm doing here. So since, you know, for 4, right, there will not be an answer for it. So it would not be in the map. So what we're going to do is put the default to be -1, because that's what they asked for, right? And then we do that for each of those numbers, nums of 1, right? And then we return the result. So like we said, we have our stack to use it for our multi-stack, right, algorithm, right? No technique. So, and then we have our map to store those numbers, right, and the result. And then we loop through those, the map, right, that has the result for each of those numbers, right? And then we can easily look up for nums of 1, which is a subset of the element of nums of 2, right? And we can, since we build it, right, we can easily find the answer of 1, right, and then store it in the thing, right? So we successfully, I think, solved it. So I spoke too soon. I need to put a semicolon. Let's press run. Looks like everything's good. Let's press submit. This is very, very good, guys. It looks like we passed all the test cases. If you guys found value, you guys understand the thought process in the comment section. If you guys are new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.